All right, 2016 BC, question 6, part A. So we're given a function that has a Taylor series centered about x equals 1 that converges to f for all x in an interval of convergence. We know that f of 1 is 1, f prime of 1 is negative 1/2, and the nth derivative is equal to this for all n greater than or equal to 2. So the second, third, fourth derivative can be determined this way. We want to find the first 4 non-zero terms and the general term of the Taylor series for f about x equals 1. So the first 4 terms is not too tricky. The general term might take a little bit more work. But here's the idea. So for the first 4 terms, what we're going to end up with is we're going to have this. So the Taylor polynomial is going to be, we have f evaluated at 1 plus f prime evaluated at 1 times x minus 1 plus the second derivative evaluated at 1 over 2, which is 2 factorial, times x minus 1 squared plus, okay, so we have 1, 2, 3. The fourth is going to be the third derivative evaluated at 1 over 3 factorial, which is 6, times x minus 1 cubed. Then put these little dot, 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 this little ellipsis here. And the nth term, the general term for all terms of quadratic and higher sort of power is going to be the nth derivative evaluated at 1 over n factorial times x minus 1 to the n. And this is true for any of those terms. So I see some stuff in here I can make a little bit nicer. All right, now I got to do some thinking. So we know f of 1 is 1. We know f prime of 1 is negative 1/2. All right, the second derivative. So to find the second derivative, I use this where n is 2. So I get negative 1 squared times, not n there, sorry, 2 minus 1 factorial all over 2 squared. That's the nth derivative. So plus that all over 2 times x minus 1 squared. And the third derivative, I do the same thing. So I have this plus. I have negative 1 to the third times 3 minus 1 factorial over 2 to the third all over 6 times x minus 1 to the third. And let me work this out first, and then I'll come back and finish this up. So this is going to all equal. We have 1 minus 1/2 x minus 1. This. Negative 1 squared is positive, so we will end up with a plus here. 2 minus 1 is 1. 1 factorial is 1. 2 squared is 4, so I get 1/4 divided by 2 is 1/8. And we'll have x minus 1 squared. Next one. Negative 1 cubed will be negative because negative 1 times negative 1 times negative 1 is negative. So I'll have a minus here. 3 minus 1 is 2. 2 factorial is 2. 2 cubed is 8. 2 over 8 is 1 over 4. Divided by 6 is 1 over 24. So I have 1 over 24. And I'll have x minus 1 cubed. All right, there are the first 4 terms. Now the general term. And I have 2 ways to go about this. And I sort of, I might be able to see something here. Let's see, do I see a pattern? the pattern's not being obvious. So like I could see I have sort of 1 over 1, I have 1/2, 1/8, I multiply by 1/4 to get up here, multiply by 1/3 to get here, but it doesn't seem to hold out. So let me go ahead and do the actual work. So let me change colors, and let's figure out what this general term is. So I need to use the nth derivative over n factorial to be that general coefficient. So I'll just put a plus here, and let's find this coefficient. The general term, I'll put a little aside here. The general term, we have -1 to the n times n minus 1 factorial over 2 to the n. And that's all going to be divided by n factorial. And I can clean that up a little bit, so I have a -1 to the n. This is in the numerator of the numerator. It will stay in the numerator. n minus 1 factorial. This is in the denominator of the numerator. It's going to actually end up in the denominator, so I have 2 to the n. And the n factorial is in the denominator. It stays in the denominator. And there's one thing that I can do here still. Well, actually, there are about two things. So in here, let me change colors again. N minus 1 factorial divided by n factorial. Remember, n factorial is n times n minus 1 times n minus 2 all the way down to multiplying by 1. This just has one extra term. So n minus 1 factorial over n factorial is the same thing as 1 over n. This right here, these are both to the n power, so I can rewrite this as -1 over 2 all to the n. So what I end up with is this. I have -1 over 2 to the nth power times 1 over n x to the x minus 1 to the n. But I'm realizing I still need my ellipsis. So let me put that in there. So the ellipsis, because this is the general term, so -1/2 to the n times 1 over n times x minus 1 to the n.